The James Webb Space Telescope of NASA is known for its ability to take beautiful pictures of space, but it also has recently made a different kind of discovery, the first clear evidence of carbon dioxide in an atmosphere outside the solar planet. We're here to discuss the recent exoplanet discovery made by the James Webb Space Telescope. Watch until the end if you don't want to miss out on any of the information about it. Could there be life on distant planets? NASA recently made a new discovery that has brought researchers one step closer to the answer. The overall structure of our solar system includes Sun, 4 smaller inner planets encircled by a belt of mostly rocky asteroids, and 4 larger planets encircled by the Kuiper belt of mostly icy objects. But what is there, though? Is beyond it? Exoplanets are planets outside of our solar system. The majority of the exoplanets found so far are in the Milky Way, which is a relatively small area of our galaxy. In the last 2 decades, thousands have been found, mostly using NASA's Kepler Space Telescope. These planets range greatly in size and orbit. Some of them are extremely large planets that are super close to their parent stars, others are icy, some are rocky. We live in the universe of exoplanets. There are thousands of confirmed planets and the number is growing. That is only a small sample of the entire galaxy. As we increase the quantity and observing power of robotic telescopes lofted into space, the number may increase to tens of thousands within a decade. Recently, the atmosphere of a distant planet has been detected for the first time with clarification by NASA's James Webb Space Telescope. Around 700 light-years from Earth, the planet known as WASP-39b orbits a star similar to the Sun. It was first discovered in 2011 based on ground-based observations of the star's host star's light dimming subtly and repeatedly as the planet transited or passed in front of the star. According to NASA, WASP-39b is a hot gas giant like Jupiter in our solar system. However, it has a diameter that is 1.3 times larger than Jupiter's and a mass that's equal to that of Saturn. This planet has an average surface temperature of about 900 degrees Celsius, which also contributes to its puffiness. It travels in a very close orbit around its star, turning around the Sun in just 4 days on Earth. So yes, 4 days would equal 1 year on this particular planet. The most recent discovery sheds light on the planet's composition, and the study's findings were published in the scientific journal Nature. According to planetary scientist and study co-author Peter Gao of the Carnegie Institution for Science in Washington, D.C., there is no doubting it. It's definitely there. He also added previous observations had given off hints of carbon dioxide, but they had never been so strongly supported. The discovery, which was submitted to arxiv.org on 24th of August, is the first comprehensive scientific finding from the new telescope to be published. It also shows how to look for the same greenhouse gas in the atmospheres of smaller, rockier planets similar to Earth. The research team uses a technique called spectroscopy. A great target for transmission spectroscopy is WASP-39b. The core element of spectroscopy is that different materials, depending on characteristics like temperature and composition, emit and respond to various wavelengths or colors of light in various ways. From there, scientists can use spectra or the detailed patterns of colors to determine specifics like how hot something is and the precise elements and compounds it's made of, all without ever taking a direct sample. WASP-39b was observed by the research team using James Webb's near-infrared spectrograph. According to NASA, having access to this part of the spectrum is essential for determining the abundances of gases like carbon dioxide and methane, which are believed to exist on many different types of exoplanets, as well as water and other gases. Researchers can evaluate slight changes in the brightness of the transmitted light across a spectrum of wavelengths to precisely identify the composition of an atmosphere because different gases absorb different combinations of colors. The first definitive, in-depth evidence for carbon dioxide ever found in a planet outside of our solar system was a small hill between 4.1 and 4.6 micrometers resulting spectrum of the exoplanet's atmosphere. NASA now has a better understanding of the planet's formation and composition thanks to the discovery. Additionally, it helps in the understanding of how much solid and how much gaseous material was used to form the planet. In a press release, Zafar Rustamkulov, a graduate student at Johns Hopkins University and a member of the JWST Transiting Exoplanet Community Early Release Science team, which carried out this investigation, said he was immediately drawn to the enormous carbon dioxide feature as soon as the data showed up on his screen. It was a special moment, marking a significant turning point in the study of exoplanets. NASA says the composition of a planet's atmosphere can tell us something about the planet's origin and how it evolved. The team's leader, Natalie Batalha of the University of California at Santa Cruz, said it's a mystery molecule and there are a number of suspects that they are questioning. She also added that finding such a strong carbon dioxide signal on WASP-39b is encouraging for finding atmospheres on smaller, terrestrial-sized planets. She also added carbon dioxide may be present in atmospheres all over the galaxy, hiding in plain sight, despite the fact that a telescope as powerful as JWST is required to detect it. One of the few molecules found in the atmospheres of every planet in the solar system is carbon dioxide. The James Webb's data also revealed an additional amount of absorption at wavelengths that are similar to those absorbed by carbon dioxide. An exoplanet's atmosphere's carbon dioxide content can provide information about the planet's formation. The planet might have been bombarded by asteroids, which could have increased the amount of carbon on the planet and enriched the atmosphere with carbon dioxide. It might also appear richer in carbon dioxide if the planet's atmosphere had lighter elements stripped away by radiation from the star. In the future, astronomers want to use James Webb Telescope to discover molecules like carbon dioxide in the atmospheres of tiny rocky planets like those that orbit stars like TRAPPIST-1. Some of those planets may be good places to look for life because they are just far enough from their star to support liquid water. James Webb Telescope will be able to detect carbon dioxide, but it's unclear whether it will be able to detect those signs of life. We haven't yet seen the time in the evolution of our universe when galaxies first started to form. The formation of supermassive black holes in the centers of galaxies is a complex process, and it's unclear whether the galaxies themselves form the black holes or vice versa. It's impossible for us to see clearly inside dust clouds when nearby stars and planets are forming, but Webb will be able to do so. There are more discoveries yet to be done, and Webb Telescope will surely do that. This much for today. If you like this video, don't forget to give it a thumbs up and also subscribe to our channel Not Alone for new knowledge about our solar system and beyond that. Bye and see you again.